Hello, I am Eleni Sautel, and I'm a second year master's student at the University of Maine studying civil and environmental engineering. Today I'm going to discuss the research project that I'm working on that includes studying the impact of weather factors on frequency of lane departure crashes in Maine. Lane departure crashes occur when at least one vehicle departs from their respective lane and results in a run off the road or a head-on collision crash. Over 30% of all roadway crashes and over 70% of all roadway fatalities in Maine are caused by lane departure crashes. And due to this, it's clear that understanding what variables are impacting these crashes is important to improving roadway safety. The purpose of this study is to explore to what extent seasonal variation and monthly weather factors impact lane departure crashes in Maine to provide a better understanding, which will then lead to improved maintenance strategies, safety, and awareness. From the preliminary analysis, it was determined to focus on rural roads, as more than 80% of these crashes occur on rural roads compared to urban. 4 facilities were considered in the analysis, including interstates, minor arterials, major collectors, and minor collectors, all of which were examined separately due to different roadway characteristics, and the analysis used crash data from 2015 to 2019. From the 2 graphs, it's indicated that monthly average daily traffic is highest during June, July, and August, which is expected because Maine is a popular summer tourist destination. These months also show the lowest crash counts. And between the 2 graphs, they're showing fairly opposite trends. Though usually higher ADT is associated with higher crash frequency. Due to this, it was decided to evaluate the effects of crashes due to seasonal variation as well. And we considered the winter season spanning from November to April and the non-winter season spanning from May to October. Due to the geographic differences in Maine, including the coastline and the mountains, there's a lot of weather variation from one place to another. For example, just during one of the 5 winter seasons that we observed in this analysis, the 2018-2019 winter season, northern Maine experienced over 100 more inches of snowfall than the coastal Maine region. From this, we determined that many weather stations should be used in the data collection process to accurately pair road segments with weather data. So first we mapped the crashes, and then we selected weather stations based on the proximity to dense crash locations, as well as based on having full data sets for the observational period. The weather data was collected from the NOAA online resource, and a total of 16 stations were collected. Using ArcGIS, the stations were mapped and Thesian polygons were created around each station. A Thesian polygon is created around a point, in this case a weather station, and all the points or road segments within the polygon are closest to that respective weather station. The segments were mapped to the weather station data to ensure accurate and reliable weather data. The analysis we conducted included modeling each facility separately for each season. And we did this with a negative binomial model with a GEE approach using 60 months of panel data for each segment. The variables we considered include monthly average daily traffic, segment characteristics, and weather factors. Once the negative binomial models were estimated, the significant coefficients were used to complete a marginal effects analysis, which show by how much the mean number of monthly crashes would be expected to change if the variable is changed by 1% compared to the mean value. The table shows some of the influential variables that were found to be significant in the analysis. This includes monthly average daily traffic is shown to be positively correlated with crashes and affects crashes during the winter period more than the non-winter period. Curb presence and posted speed limit were also significant, and they also showed more effect during the winter period than the non-winter period. Weather variables that proved to impact crashes include the number of days in a month with at least 1 inch of snowfall, or the number of days in a month with at least 1 inch of rainfall, maximum precipitation, and maximum temperature. Precipitation and snowfall variables were found to be positively correlated with monthly crash frequencies for all facilities during the winter and non-winter months. An interpretation of the results includes, as the number of days with more than 1 inch of snowfall increases by 1% from the mean crash frequency, it is expected to increase by 0.5% on interstates, 0.05% on minor arterials, 0.04% on major collectors, and 0.03% on minor collectors. In conclusion, the developed models and the marginal analysis results indicate a significant difference between the coefficients of the models for winter and non-winter periods, indicating seasonal variability. Also, the winter period weather affects crash frequencies much more than the non-winter period crashes for all facility types on rural Maine roads. The weather variables that impacted crash frequency the most included the number of days in a month that experienced 1 inch or more of snow or precipitation. Some recommendations include using road weather information systems data, because this would include more accurate and reliable weather data for segments. However, this data was minimally available for this project. Also, in the future, investigating more weather variables would be useful, including visibility and wind.